Okay, today we're going to finish up Unit 1 and we're going to talk about, start to introduce us to this wonderful thing called the periodic table. Okay, so, and the elements that are contained on the periodic table. And we'll hear a lot about it throughout the year, so we're kind of just starting with the basics for today. Alright, first off, all elements, as we've already talked about, are pure substances, and that is simply going to mean that all of the substances have the same composition and the same properties throughout the entire thing. Okay, so they're uniform. And they're organized by these properties on the periodic table. And this is something that we will continue to come back to as time goes on, but there is a very specific shape to the periodic table and what this looks like, and we'll kind of dive into this, that everything has a purpose, and this is something that's been constructed by humans and scientists as they discover the properties. So there's a method to the madness, so to speak. Now, what each square will typically show you in almost every single periodic table is the name and the letter symbol for each element. Okay, and usually the symbols relate to their English names, that they make sense. For example, carbon is abbreviated by a capital letter C, oxygen is a capital letter O, so those, what I refer to as, make sense. But some of them come from older names, which are typically Latin. So this is when you're going to get into a situation where the symbol doesn't look anything like the word. For example, gold symbol is AU, which comes from the Latin word aurum, and iron is another one that can be confusing, and iron symbol is Fe, which is going to be from ferrum. Okay, now, before you start to panic, I am not going to make you memorize verbatim the entire periodic table. We will have to know a lot of things about it, different sections, different rows, different properties, but I am not going to take that away from you, I don't think, throughout the entire year. Okay, a few other vocabulary terminology things that we got to talk about. The first is what are called groups. They're also called families. These are the vertical columns of the periodic table. They are numbered from 1 to 18. So as you're going across the periodic table, you're going to start with 1, 2, 3, 4, 5, etc., all the way up to 18 on the other end. And these are in vertical families, vertical columns. Just like similar families have similar genes or similar characteristics, chemical families are going to have similar chemical properties. So they're going to behave the same way. They're going to combust, they're not going to combust, they're going to be certain types of metals or certain types of elements. Okay, now periods, on the other hand, are going to be opposite. They are horizontal rows. So when you're thinking about the periods, you're going to be numbering down, 1, 2, 3, etc., etc. These are going to go all the way up to 7. Okay, there's 7 horizontal rows. Now, they're not all complete horizontal rows, but there are 7 rows. And this is going to be opposite. If the vertical columns have similar properties, then across horizontal rows, those properties are going to change. Okay, so you're going to get a lot of variability from things that are extremely reactive to things that are not reactive at all. Now, there are 2 rows that kind of almost look detached down from the bottom. They are what we refer to as the lanthanide and the actinide series. Okay, so they're way down the bottom if you look at a periodic table. These rows actually fit in above number 57 and number 89. So it's really just a ease of printing type deal. That's the reason that they're down below, but they do actually fit in, and I'll show you what that means. So they're only at the bottom of the chart to keep, or the bottom to keep the width of the chart smaller. It'd be really difficult to get that printed on one page where we could actually read it. Okay, now we're going to get into a little bit of some types of elements. Okay, so if you remember, elements are going to be our pure substances, and this is going to be a further break of elements, and there's going to be 3 groups that we're going to talk about for different type of elements. The first one is going to be metals. Okay, metals, again, some of this stuff we should be, in pretty decent shape on. These are elements that are good conductors of electricity. Okay, if you think about it, if you have wiring, there's usually a metal inside the wire because it conducts electricity well. Most metals are solids at room temperature, okay, for the most part. They also have a few characteristics. The first one is that they are malleable, meaning they may be rolled or hammered into thin sheets. If you think about aluminum foil, okay, aluminum foil is a big piece of aluminum that's been rolled out or hammered into a thin sheet. Ductile refers to the fact that metals may be made into a wire. Okay, you can take it and you can stretch it into a wire. Okay, again, hence coming back to that whole reason as to why we have a lot of copper wiring and other metal wiring. They also have very high tensile strength, okay, which means they can resist breakage when they're being pulled. Okay, you can pull on it and not split it apart. So that's what we refer to by tensile strength. They also are very what we refer to as lustrous. This is a fancy word for shiny. We're going to find later on that that is all due actually to electron movement and electron activity. And if you look on this periodic table up here, all of the, up in the upper left hand corner, all of the ones that are in red, okay, these are typically our metals, which you can see, this may not be completely 100% accurate, but it's pretty good representation. As you can see, this is most of them. Okay, so most of the elements on the periodic table are metals. Okay, and there is some variability. Not all of them are good conductors, but for the most part, these are the characteristics that make up metals and things that we think of on a regular basis. Again, copper, gold, silver, those types of things. Okay, so if a whole chunk of those were metals, then we're going to have the opposite, and that's going to be nonmetals. And you can see now these are the red ones that I've highlighted up here. Okay, so for elements, we had metals was group number 1, nonmetals is going to be group number 2. And the good news is they're kind of opposite from the metals in the fact that most nonmetals are poor conductors of heat and electricity, which again is also going to be due to electrons. We're going to hear about those a lot. Most of them are gases at room temperature. Okay, there are some solids, but they're usually very brittle. Okay, this is actually an example of sulfur solid right here. Brittle means that if you tried to hammer it into a thin sheet, like the malleability, or pull it into a wire, that it would crack and fall apart. Okay, so that's what brittle is going to mean over there. Here is bromine. Bromine is actually a liquid at room temperature. This is chlorine gas that we saw earlier with the sodium chloride example. And then you've got some sulfur over here. Those, again, those are nonmetals. All right, kind of like Goldilocks and the Three Bears, we've got the metals, we've got the nonmetals, and then we've got the metalloids. Metalloids are elements that fall right smack in the middle. They've got some characteristics of metals and some characteristics of nonmetals. Okay, so both of those are going to be in play there. They appear along a staircase line on the periodic table. Let me see if I've got one. Okay, let me come back to that. So I must have deleted it here, but if you look at most periodic tables, there's a stair-step line that kind of runs right here, and that's what I mean by the stair-step line. And we're going to color one of these in class and label it to get it right. So, but anyway, you've got boron, silicon, germanium, arsenic, antimony, and tellurium. Okay, and those are going to be our metalloids. Now, all of them are solids at room temperature, and this is kind of what I mean where they fall in the middle. They're less malleable than metals, but they're less brittle than nonmetals. All right, so they're kind of right smack in the middle of being able to be manipulated. They're also semiconductors, which means that they're okay conductors of electricity. They're not as good as metals, but they're also not as bad as the nonmetals. Okay. Now we got one more group of elements that we need to be familiar with. These are the noble gases. Alright, noble gases are generally very unreactive. They're actually a special group of nonmetals. And that special group of nonmetals is found way far to the right of the periodic table. And when we come back to the periodic table in unit, I think it's unit 3 or 5, I can't remember, we're going to talk about why they ended up there. But they're very unreactive, and the name comes from looking at society and history, and that nobility in a lot of ancient societies didn't like to mix with the other classes. They felt themselves too important or too worthy to mix with anyone else, and that's where the name noble gases come from. They're very unreactive, and they're in the far right of the periodic table. Helium, okay, helium balloons is going to be one of those. Neon, where we get our neon signs, that's another thing. And when we say unreactive, we usually find them by themselves as elements, and we don't find them combined with other atoms in compounds. Now we're going to, let's color is for class. We're going to color in a periodic table and label it because you've got the facts. Now we need to just get the application and understand the practicality of it. Okay, a couple other terms that we need to introduce have to deal with chemical compounds. The first one being what's referred to as a molecular compound. Okay, anytime, and we're going to do a lot more with this as the year goes on, but if I start introducing it now, we've got a shot at remembering it. Okay, molecular compounds are ones that are covalently bonded, and that involves sharing of electrons. Okay, all you have to know right now is the definition. That's it. But we'll start to introducing those concepts. And molecular compounds usually happen between nonmetals and nonmetals. So when you have two nonmetals, okay, that's what we're usually referring to here. Now, the number of atoms of each element contained in a single molecule of the compound is represented, this will make more sense. For example, this is nitrogen dioxide. You've got one nitrogen and two oxygens. This is going to be a organic compound that's got some carbon and some hydrogen and some chlorine. But again, you've got one carbon, two hydrogens, and two chlorines on that one as well. All right, in comparison, we've got ionic compounds. Ionic compounds is a metal and a nonmetal, and this is when electrons are going to be transferred. And we're going to talk about this a little bit later, but again, just know the definitions at this standpoint. It's a simplest ratio of the compounds, ions, and with ions we've got two other terms. Ions are charged particles, meaning they have an imbalance of a positive or a negative. Anions are negatively charged ions. Cations are positively charged ions. And the way that I remember this one is the cation has the T right smack in the middle of it. For example, again, sodium chloride is made up of the sodium ion and the chloride ion. And sodium is your metal, chloride is your nonmetal. This is going to be hugely important for the rest of the year in order for us to keep straight. Okay? All right, so there's our basic intro to the periodic table, and we'll do some activities in class.